This task has been given as a part of the data science internship by Oasis Infobyte. So under this task, you can see that I have executed the code which is needed for this task to program. So I will be explaining the whole code which I have executed. So firstly, import NumPy as MP and import pandas as PD. What does that mean? Pandas library is a manipulation library to manipulate and analyze libraries flexibly. NumPy is a library for programming language supporting multidimensional arrays and also mathematical operation on these arrays. So we import the following libraries NumPy and pandas at the beginning. Next, df is equals to pd.read underscore csv, and then we write the name of our file. So we are just trying to read a CSV file which is saved in the directory in my computer using the pandas and Python. This code will load the data from the CSV file in the pandas. And next line we use a command df which actually print the entire data frame to the console. Next, we write the code df.shape. What does that mean? It actually represents or returns a tuple representing the dimensionality of the data frame df. Which what does that mean? That it means that this will print a tuple to the console, where the first element is a number of rows and the second element represents the number of columns in the data frame. And after executing the code df.shape, we see that 150,6 is the output, and it's actually matching with the result which we got from the previous command, that is df. There we are seeing that 150 rows in 6 columns, and this is also showing 150,6, that is df shape is returning the correct value. Next we write df is equals to df dot drop within first bracket columns is equals to within square bracket within quotes id. What that does mean, df dot drop is a function that removes specified levels from rows or columns, and here we written as columns is equals to within square bracket within quotes id specifies that we want to drop the column with the name id. So that is previously, as we have executed the code df, we saw that we have a column named id, so we now want to drop the column using this code. And next we use df command to print the data frame, the changed data frame into the console. And here we see that the ID column, which was previously visible, is now dropped successfully. And now we have 150 rows and 5 columns. Next, we give the command df dot head. What does it mean? That it means that it will return the first 5 rows of the data from df. Next, df species dot replace iris cetera colon 1, iris versicolor colon 2, iris virginica colon 3 in place is equals to true. What does that mean? df species dot replace the function that replaces specified values with others. Iris cetera colon 1, iris versicolor colon 2, iris virginica colon 3 is a dictionary that maps the original values to the replacements. In place is equals to true means the operation is performed the data frame directly without returning a new data frame. So it will make the changes in the original data frame. It will not create any new data frame. And next we use the line command df to print the data frame, and we see that from the previous command, as we have executed it, the iris cetera in the specialist column is replaced with 1, iris versicolor with 2, and the iris virginica with 3. So we can clearly see the difference that the code is successfully replaced iris cetera with 1, iris virginica with 3. Now x is equals to pd dot data frame within first bracket df dot columns is equal to sepal length centimeter, sepal width centimeter, petal length centimeter, and petal width centimeter dot values. What this means, the PD dot data frame df columns is equals to the name of the columns, which it creates a new data frame. Now we are creating a new data frame with only those specified columns, and dot values converts the data frame into a numpy array. And when we print x, we get that array. So we see here that our data frame is converted into array, and the values of this particular columns which were in the data frame are now converted into arrays. Now, in the next command, we write y is equals to df the species dot values or ratio minus 1 comma 1, and next we write y, that is to print the command. So after executing the df the species dot value selects the species column in the data frame and converts it to a numpy array. We are selecting the species column from the data frame, and now we will be converting it into the numpy array. Reshape minus 1 comma 1 reshapes an array into a two-dimensional array with one column. That is, the array will be a two-dimensional array and it will be having only one column. The minus 1 means that the size of the dimension is inferred from the length of the array and the remaining dimensions. After we execute the code, we will be getting y as a two-dimensional array containing the values of the species column from the data from df. And we have already seen that the species column is now converted into and two-dimensional array, and it's only written 1, 2, and 3. That is Iris Cetosa, Iris Virginica. Those values which we have replaced with 1, 2, and 3, we have only can see. So from sklearn neighbors import k neighbors classifier from sklearn dot model underscore selection import train underscore test underscore split, and from sklearn import matrix. So all the libraries which we need. So we are importing the k neighbors classifier to from the sklearn.neighbors module, which is and this class is used for the k nearest neighbors classification. Next, we import the train underscore test underscore split function from the sklearn.model underscore selection module, which is used to split arrays or matrices into random train and test subsets. And lastly, we import the matrix module from the sklearn library. The module includes core functions, performance metrics, and pairwise metrics and distance computations. Next, we use a code x underscore train, comma x underscore test, y underscore train, comma y underscore test is equal to train underscore test underscore split, x comma y comma test underscore size is equal to 0.30, comma random underscore state is equal to 42. What does this code means? It will split the data into training and testing states. The test underscore size is 0.30 means that 30% of the data will be used for testing and the rest will be used for training. And it is 70%. And the random underscore state is equals to 42 means it is used for initializing the internal random number generator, which will decide the splitting of data into train and test indices. Next, we write x underscore train dot shape and y underscore train dot shape, which actually will print the number of rows and columns in the x underscore train and the number of rows in y underscore train. And it should be noted that the number of rows in both these cases, x underscore train and y underscore train, should be equal, it should be same, and we can see that they are actually same. So is 105. Now we write the code k is equals to 6, k in CLR is equals to k neighbors classifier within first bracket k in CLR we printed. So k is equals to 6 means that the set of number of neighbors to consider will become constrained 6 neighbors. K neighbors classifier and this first bracket k initializes a k nearest neighbors classifier with k neighbors after we execute the line of code. K in CLR will be the k nearest neighbor classifier that considers the six neighbors when making predictions in that case. So we have already executed the code and we can see it is written in underscore neighbors equals 6, that is considering six nearest neighbors. Next, KNCLR dot fixed x underscore train, comma y underscore train. What does that mean? X underscore train is the training data and y underscore train is the corresponding labels. And this code trains the classifier to associate the data in x underscore train with the labels in y underscore train. After we execute this line of code, the k nearest neighbors classifier KNCLR will be trained on your data and ready to make predictions. Next, we write y underscore pred is equals to knclr dot predict x underscore test. X underscore test is your test data, and this code. What does it mean? It makes predictions for instance in x based x underscore test based on the k nearest neighbors algorithm. Sorry. So after the line of code is executed, we see that the y underscore pred will be a numpy array containing the predicted levels for your test data, which is not shown here, but this code implies this following output. And the last line we write code is matrix dot accuracy underscore score y underscore test dot y underscore grade into 100. So y underscore test are the true levels for your test data, and y underscore pred are the predicted levels. Matrix accuracy underscore score y underscore test y underscore pred is actually computes the accuracy score, which is a fraction of correct predictions over total prediction. That is the total number of prediction out of the total number of predictions. How many predictions are correct? So we will be seeing that. So multiplying by 100 converts a score from a fraction to a percentage. So when we are multiplying it with 100, which is actually converting the score from a fraction to the percentage, and after we execute the score, the accuracy is coming to be 100%. That means the accuracy of the k nearest neighbor classifier expressed as 100% is expressed as 100%. That is, the k nearest neighbor classifier is totally accurate, is completely accurate to perform this task. So, thank you.